All right, let's have this second example. It says there a 1,500 kilogram rocket is to be launched with an initial upward speed of 50 meters per second. And so in order to assist its engines, the engineers will start it from rest on a ramp that rises 53 degrees above the horizontal. And so at the bottom, the ramp turns upward and launches the rocket vertically. Okay? And so the engine provides a constant forward thrust of 2000 newtons, and friction with the ramp surface is constant at 500 newtons. How far from the base of the cliff or base of the ramp should the rocket start as measured along the surface of the ramp? Okay? And so if we are going to plot our given now, okay, and so we have there first is of course the mass of the rocket that's already given at 1,500 kilograms. And then we have here 50 meters per second, which is the initial upward speed. Okay, although take note that although it says here initial, it's not actually the start of the problem. And so it's telling us that before launch, and so yung launch niya dito, that is at 50 meters per seconds. Okay, so let's identify yung before and after natin, or point 1 and then point 2. Let's say, so dito yung point 1 natin, and then ito yung point 2. And so meaning at point 2, right before it launches upward, the speed there, and so let's have V2 is equal now to 50 meters per seconds. And so let me just 50 meters per seconds. Okay? And so in order to assist its engines, the engineers will start it from rest. And so meaning at point 1, it started from rest. Therefore, we can say that V1 is equal to 0. And so it started from rest. And then, of course, we have there the angle, which is 53 degrees above the horizontal. And so at the bottom of the ramp, the ramp turns upward, and then the engine provides a constant thrust of 2,000 newtons. Okay, meaning the engine provides a force of 2,000 newtons that helps the movement of the rocket. Okay, so meaning from rest, and so yung engine nakakatulong siya kumbaga dun sa paggalaw ng rocket. So we can say that the thrust force, let's have that as F sub T. And so it's directed this way. So that is 2,000 newtons. And so 2,000 newtons. And then we have there the constant friction by the ramp. And so meaning, and so of course that's friction, it's directed opposite. So we can say that that is F sub K. And so 500 newtons. It's directed opposite. And so pag ganun yung direction niya. Alright? And so how far from the base of the ramp should the rocket start? And so how far, what are we looking for in this problem? And so we are basically looking for, and so read ko lang siya, yung distance. Okay? And so meaning from that point to that point, and so gaano kalayo dapat? Let's have that as S. Okay? S yung kailangan natin. Now, if we are going to analyze further, and so that is launched at a certain height, no? And so at a certain height, so let's say that that is y sub 1. Okay? Y sub 1, it has a value. And then dito naman sa point 2, it's on the ground. So we can say that y sub 2 is already at 0. Okay? Kasi nga nasa ground na siya. Ayun yung given natin. Now, sige, let's apply and conservation of mechanical energy. And before we go to our equation now, we notice that there are other we have the forces, the other forces. Let's have that as others. F others, we have the thrust as F sub T, plus we have the frictional force. Okay? And so pwede nating pagsamahin kasi nga, so they contribute, they are dependent. They are dependent on this one, the first situation right there. So we can say, and that is 2,000 newtons minus, we have there 500 newtons, which is now equal to 1,500 newtons. And so we have there the other forces, or we have the non-conservative forces. Okay, pinagsama lang natin yung non-conservative forces. Okay, now, if you are going to substitute already, we have there K1 plus, and so meron tayong change in potential energy. So we have there UG1 plus, and so the work done by the other forces, and then that is equal to the kinetic energy at the second point, and then the potential energy at the second point. Again, we cancel out immediately those which are equal to 0. And so it started from rest, therefore we can say that K1 is equal to 0. And then the potential energy at point 2 is also equal to 0. Kasi nga, ayan, nasa ground na siya. We are now left with UG1, or the gravitational potential energy at point 1, plus the work done by the other forces, and then we also have the kinetic energy at point 2. If we are going to expand this, UG1, or the potential energy at point 1, we have mg y1 plus we have the work done by the other forces, so we have their F others times the distance, which is our concern, is equal to 1/2 the kinetic energy, so that is 1/2 mv2 squared. Okay, yun yung mv2 natin. Okay, and so take note that we are concerned with S. Yung S yung hinanap natin. Pero balikan natin yung illustration natin. We can actually have that as similar to like this, 'di ba? This is theta. Sabihin natin that is theta at 53 degrees. This is y1, and then this is S. For us to be able to relate now the y1 and then S, kasi wala tayong value ng y. We don't know the value for y, but we have there the common variable, which is S. So, pwede natin sabihin na sin theta is equal to y1 all over S, or y1 is actually now equal to S sin theta. Okay? And so para at least common yung S natin, we have there, substitute na natin dito, mg S, wait lang para, mg S sin theta plus, and so F others, and then S is equal to 1/2 mv2 squared. And so we factor out S para mas madali. And so S is equal to mg sin theta plus the force done by the others equals 1/2 mv2 squared. Okay, and so we simply isolate S, so that we have an mv2 squared all over 2 times, we have there, and mg sin theta plus F others. Okay, and so substitute na natin yung values so that we can solve for S. We have there 1,500 kilograms times the speed at the bottom, and so 50 squared, times 2 times, we have there 1,500 times 9.8 sin 53 plus 1,500. Okay, and so if you're going to solve for that, we would have the value for S as 141.6 meters, or S is equal to 142 meters. Okay, so there, meaning the rocket, for it to be able to be launched at 50 meters per second from the bottom of the ramp, it should travel a distance, or the ramp should be at least 142 meters. Okay, that's for the second problem.